So I just want to, this will be a good refresher, and it'll also sort of help you with one of these problems on the activity. And I think it's a little trickier. And, you know, as a hint for you guys, you might see a problem like this on the exam. So, you know, you might want to take know how to do this kind of thing. So here's how this kind of thing goes. And I forget which problem this was like on the activity. Maybe like 14. I don't know. But you'll see what I mean here in a second. I'm going to write down a problem like this, a system of equations. A specific one in mind here. So I made up this problem. So it's 4x plus a times y equals 6, and negative x plus 2y equals negative 1. And so there's this a here in front of the y. And that is sort of like a variable, or it's some number, but we don't know what number it should be. And so there's a problem like this on your activity where there's some number, and here's what I would ask is, for what value of a does this have does not have a unique solution? So does this system not have a unique solution? And so when I use the word unique, this is when what yesterday I would have said exactly one. So in which value of a can I pick so that this system does not have exactly one solution? Meaning it's either going to have infinitely many or it's going to have no solution. Right? You want to find the value of a that makes that happen. And so there's maybe a couple different ways to approach this. But basically what you would want to do is try to solve this system. And somewhere a is going to kind of just come along for the ride, and we're going to get some equation that maybe we can solve for a that'll make this happen. So let's kind of see what that looks like in practice. Let's try to solve this system. And so since a is just some number and I don't know what to do with it, if I was going to do like the elimination method to solve this system, I probably don't want to cancel out the y because a is just there. I don't know what to do with a. So let's not cancel the y here. Let's maybe try and cancel the x. Let's try and get these coefficients to be opposites so that the x's will cancel out. And then we'll see what happens with the a as we go. So I have 4 and I have negative 4, the coefficients for x. And I want those to be opposite. Well, this is negative 1, this is 4. Maybe if I just multiply this second equation by 4, I'll get negative 4 plus 4 is 0. So let's multiply the second equation by 4. Here are my new equations. So I have 4x plus ay equals 6. And I have negative 4x plus 8y equals negative 4. Like so. So just multiply the second equation by 4. Now we're going to add these together. If we do elimination. The 4 and the negative 4 will cancel. Here I'll get 8y plus 8y. Maybe I should have picked a different name than a. A and 8 sound very similar. Anyway, ay plus 8y. And then I have 6 plus negative 4 is 2. Okay. So I'd like to simplify this. You know, I want to solve it for y. If I'm trying to solve this system of equations, I want to solve this for y. That's like the next step to get y by itself. But I have this a plus 8y, and I want to write that differently. And so there may be 2 words I could say here that would describe what this is going to be like, or my method here. Yeah. I'm tempted to say the word factor. I want to factor out a y here, because both of these terms have a y in them. I can factor out the y. So what I'm going to say is factor out the y, which in some sense means I'm just going to pull it out. And I'm going to take whatever's left over and write it in parentheses. So I'm going to factor out the y. And if I take the y out of the parentheses, what's left over? Well, there's a plus 8. There's a plus 8. Okay. So if it's been a while since you factored, this seems like magic or something. That's okay. Although we do want to get sort of used to doing this because it's going to come up a bunch of times in this course as we go. Later on, it'll come up when we do matrices and stuff. And so it's good to get sort of comfortable doing this factoring thing now. So it's just looking for things that these terms have in common. They had a y in common, so I can pull a y out. The other word I can use here that's the same thing is distribution, right? If you wanted to go from here to here, maybe you'd feel more comfortable doing that because you would just distribute this y, right? I would distribute the y to the a, I would distribute the y to the 8, and then I get exactly what I started with. So factoring is kind of just like doing the distribution backwards, in some sense. Although, let's just say that. It's kind of like doing it backwards. So that's factoring. And we're going to do that kind of thing again in the future, so it's good to get used to it. So I have a plus 8 times y equals 2. And if I was going to solve this for y, probably the last thing I would do, a plus 8 is just some number. It's just a number. It's a weird looking number because of this a, but it's just a number. So I can divide by it, perhaps. And I can get y equals 2 over a plus 8. So just divide both sides by a plus 8. And the a plus 8 cancels on the left side, and I get 2 over a plus 8. Okay. So let's look at this right here. This y equals 2 over a plus 8. So remember, a is just some number, and we were looking for what value. We're looking for a particular value of it that would mean that I don't have a unique solution. So I don't know. Can anything weird happen if a took a certain value? Is there any value that a could take over here that would make this bad or weird or something? Anything go wrong? I don't know. Does anyone want to try and guess? Anyone have any ideas? Any values of a that would make this bad?
-8.
Yes, exactly. Thank you. If a is -8, we're out of luck because I'll get -8 plus 8 at the bottom, and that's 0, so I'll have 2 divided by 0, and that's bad, right? So I'll erase over here and write down that conclusion. So if a is -8, we have to divide by 0, which we can't do. A equals -8. And y equals 2 over 0, which is undefined, of course. And so that makes no sense, right? That doesn't make any sense. And so we got something that makes no sense. I mean, if I were to go back, what's this really going to tell me? In other words, if I were to plug in -8, I would get the equation 0 equals 2. If I plugged it in here, I'd get the equation 0 equals 2. This is maybe one reason why, maybe gives us some insight into why I can't divide by 0, because if I could, then I could say that 0 equals 2, but that's not true, right? So I can't divide by 0 because 0 equals 2. But in trying to solve this, if a is -8, I end up with this false statement. And as we saw the other day, that means that this system of equations has no solutions. So there are no solutions. And so there are no solutions if a equals -8. So what we see is that if a is -8, there are no solutions. So there's not a unique solution because there's no solutions at all. And if a were to take any other value, we'd be okay. There'd be a unique solution because then I could solve this out. The only way we divide by 0 is if a is -8.